Okay, so this is like the first day, Monday of our like 2 gig week. We're gonna discuss like the approach, configuration, and like how we want to measure our work, and like who is picking what team from the list of the teams that is part of our epic. So like we discussed that after Friday, we discussed that we actually think that using the high CPU machine will give us much faster turnaround time. So we settled on using N2D high CPU 4, which is like 4 vCPU with 4 gigs of the memory. And we also additionally configured 4 gigs of swap. It's gonna be like our baseline testing configuration, but we're gonna be augmenting this VM with setting of kernel mem parameter, which actually gonna allow us to limit to whatever memory spec we need. So we're gonna be like tinkering only with like single parameter, but still having like high CPU count. We kind of like aim to run successfully GitLab on mem 2 gigs, which gonna basically we're gonna edit etc default grab and then update grab and restart VM to have this new setting. We should probably discuss like our teams for today. Alexi, I think that you had some questions about our teams.
You mean topics?
Yes, topic, team, however you name it. Yes.
Yeah. I was curious about garbage collection like tuning. So I remember we mentioned that we probably want to tune like how aggressive garbage collector is, but I wonder if this already goes into this investigate a big difference between idle and runtime memory, or is it different from garbage collector tuning and experimentation? So
I think like in my perception, they are kind of like the objective is slightly different. Because like garbage collection with compacting GC is about like efficient memory page use and like being able to like to wipe out memory pages that are not needed. Compacting makes you like, I mean, any allocation creates a lot of data, a lot of memory fragmentation. So like you have 4K page that is used maybe in 10%, and compacting makes you move these blocks into one page, so you could like recycle that one. So I think like GC tuning is about like figuring out if we can like map maybe pages being used, is compacting kind of working? Can it like move things around to like to recycle these pages? How we can configure like to be more aggressive in recycling these pages? Or is it even like happening? How many pages maybe we have like these, let's say, half empty, or maybe like even less empty? Where like the second one, what was like the second one that like you mentioned, the name of that?
Investigate a big difference between idle and runtime memory.
Yes, where I think the second one is about trying to like dump objects in the memory, trying to understand. I mean, it's also connected like with looking at the content of the memory pages, but I'm kind of thinking more from the perspective, are there parts of the code base that may be holding like a big amount of the data over time? They are kind of prepaid, so they kind of be garbage collected. Can we like maybe measure like how many strings we have? Maybe they are like duplicated. Are they like kind of growing over time? Are symbols like growing over time and things like that? So like I think it's more about trying to understand why our runtime memory is increasing. I mean, we know that one aspect is like this memory fragmentation, but I'm kind of thinking more from the perspective of are there like the code in the GitLab that maybe it's holding very big objects, a lot of references that maybe if we would like nullify a few entries, it would make GC actually be able to wipe out that. So kind of like, I'm thinking more about maybe trying to understand and build like the reference tree, trying to find the root references that GC is using to traverse this tree of the objects. So it's more about, I guess, this aspect. Where like one GC tuning is about like, I mean, we know that we hold a ton of memory, but can we make this representation compact? So like have much better page utilization. But then the second one, we know that we are holding a lot of memory, but is this actually needed to be held? Can we somehow like nullify and recycle that? So make like GC to be able to discard these blocks of the memory being used. So you would not, so it would not even have to like to recycle them, or like it would not have to compact these pages in the first place. So they are like very similar, but I think the direction between them is like somehow different. Like you're looking at different aspects. Like one is like language tuning, where the second is more about application tuning, I guess.
Yeah, but about this GC tuning, we currently listed it under topic Ruby 2.7. Do we need a separate topic for just outside of Ruby 2.7 to play with garbage collection, let's say, params? Because we don't currently have any separate topic for garbage collection. Like we only have this GC tuning under Ruby 2.7, which I don't know like how it could affect the overall memory usage.
I'm not sure like how to.
So you think like install 2.7 and try compact and try also like different aggressive models and.
So I'm kind of like not. I'm not sure like how to grab that on the like issues and topics. But if you decide on like on working on that, like you can like rewrite these topics to make it meaningful and maybe create the issue and keep track of that. Because like I'm kind of like expecting that as soon as someone starts looking at that, you're gonna like discover a ton of other stuff that's gonna be another topic of the investigation. So like I would kind of expect that like, I look at only this small aspect, but another topic is look at this specific aspect that I didn't look at yet. So I'm kind of expecting that like, this is like the headline, which gonna span maybe 2, 3, 5 subtopics to this headline that we may then pursue or not pursue. So I would be not attached to the current topics because this is like kind of draft. Like look at the topics as they are. Try to find like the objective that you are gonna be focusing at, and try to like to create another topic, so like another like discussion points about this aspect that you look at, like what may be worth investigating further.
Okay. Should we select on topics now, or should we wait for Matthias until after lunch and then build with them?
I think like we should select, like Matthias can like follow up once he's done.
Okay.
Pick another topic.
Any preference?
I was kind of like about the timeline. I was kind of thinking that as the outcome of the day, I was kind of thinking that for each topic that we choose, like we move this topic investigation into dedicated issue, and like we kind of like start like having our thought process, metrics, data, parameters that we test. This kind of like a log in the separate issue that is attached, and this is like how we migrate this topic into like the work item that like we work. And I was thinking that maybe because like we have this meeting at the same time every day, like tomorrow or like this 1 hour before like this meeting, each of us would look at everyone's results and read this log of the investigation. And like then we could, on this daily sync meeting tomorrow, discuss like how it went. Was it hard? Like what else could be interesting to investigate it? So I was kind of thinking that like our daily sync would look like that we focus on reviewing what every one of us did like last day by going through this issue that like you populate with the data. But then like we pick like another topic or maybe the same topic if it's still worth investigating for another day. So I'm kind of thinking that like if we choose the topic, we move this topic into like a full-fledged issue as something that we work on, and we keep like a log of the items that we like investigated as part of this topic, or maybe another items that may be worth investigating later as part of that issue. So, Nicola, maybe you have some preference for the topic first. You are muted.
Yeah. Before we start with the topics, I just want to go with baseline comparison. Like, should we list those metrics and how to use them in the issue where we like configure the setup and everything else, so we can always use the same metrics?
I think we should, but I'm not sure we figure it out like it fully, because
yeah, I'm not saying that we should do it now, but like it would
okay.
be beneficial to define them so we can like do the comparison.
Yes, but also everyone could like chart a bit different like values from Prometheus during the run, so it may be a bit different like based on issue. But yeah, I agree.
So I was thinking that I will spend some time like today on like getting these like baseline metrics from the GPT, and like we would have like the calibration session on the metrics like tomorrow. So like we would like work on the topic like today, kind of like maybe in our own way, each of us, but like tomorrow like we would start refining like these metrics basically.
Yeah.
So
I was thinking something about like we'll have a bunch of metrics. We need to measure them on idle, let's say, like, because some changes could make the idle consumption as well. Like then we need to run GPT, and then we need to chart how the growth rate, maximum, minimum, probably. Like, so.
Yes, and it's actually tricky because like I'm not sure if there is like one fits all type of the metric. Like
Definitely.
If we talk about the GC compact, I guess like there is like different set of the metrics, or like different set of the data that you are looking at. I think like from this baseline comparison, I'm more aiming like on this like to be a summary of the week. Like we have this baseline comparison, we started with that. We integrated all our improvements from various parts, and we kind of resulted in this kind of like outcome. This is like how memory we like reduce, maybe this is how many more requests we are able to produce. So I would like not be super attached to the GPT details, but I think like throughout the week we should figure out a way to make this meaningful comparison after this week, like how much gain we achieved since like now, before like we made any change, and once we maybe integrated all our changes. Because like I was also thinking that if we find like some improvements, I would like to join these improvements on Friday and see like exactly like of our joint effort, like how much we can improve GitLab, like how much we can gain on the memory usage. So like it's hacking investigation, but like I would kind of like to join all our improvements at the end. So kind of try to like whatever you do, like try to make it in some form that is like reproducible from this issue log to someone else. That like it goes through these steps, and it can to some extent reproduce like this investigation that you did. So I think that this is my idea behind it, and I'm not sure like what is yours, but I'm kind of sure that it's gonna be changing throughout the week, the more topics we kind of investigate.
Cool. Makes sense. Okay, we can go to topics. I look this one, investigate used gems, and I have a question related to, okay, we can measure like the biggest one and try to remove them from the code base, but can you maybe explain how we could figure it out that they can be executed externally? What do you mean by that?
I was thinking that maybe in some cases, if gem maybe is often or rarely used, maybe it would be, for example, loaded by the dedicated process. Maybe it could be loaded only by Sidekey or someone else, or maybe it would be executed by dedicated, let's say, bin command. So this was like my idea. Like, if you would like remove the biggest gems, how much gain it would allow us, how often they would be like, let's say, maybe used, or like in what circumstances. And if you would have to like remove them and still execute them in some different form, maybe rewriting them in something more efficient, how complex it would be, and like what methods we would have. So I guess like it's about like finding if we can remove some dependencies basically, or can we move these dependencies to be executed in some different form to kind of reduce these idle and runtime memory usage basically. And it's also kind of vaguely connected with my like suggestion about like memory, like do these gems like contribute to the runtime memory over time when they are executed? If yes, like how we can recycle the memory of these gems and things like that. So I guess like this is another like all of that is kind of like interconnected, but I'm kind of more thinking about as part of this topic, we have like the big gem. Can we remove this big gem? Like what it would take for us to remove that? Maybe like we know that some parts of the GitLab gonna be defunct right now, but we remove, like we comment out, we try to run and see like how much it brings us the benefit. Does it bring like maybe like 100 max in total, which would be like pretty big saving? And now if you would have to make this permanent change that we remove that, how like we still are able to run this somewhere else maybe, or maybe we can replace it with something more efficient. I don't know. I'm kind of looking into some this kind of like investigation, like what we can do with that.
Understood. Thanks.
Okay, so what we are focusing on today. Alexi, what about you?
I was thinking about something small to calibrate my, let's say, environment to actually understand how to do this fast. So it would be either like Puma something because it's simple to execute, but I could concentrate on how I measure, how I work with the environment, how I produce its results, how I compare. So maybe I will take Puma if it's okay with you, or Ruby 2.7. So whatever you think would be beneficial for the first day.
I mean, like pick anything that you want. There is no really like I'm not sure like which one of them is like
okay
or not. So like,
but I have one question about
anything that you think that is like interesting for you.
Yeah, I have a question about topic Ruby 2.7. You mentioned does compacting GC break copy and write from forking? Do we use copy and write from forking currently?
Yes.
In Puma.
We use in Puma. Yes.
Okay. Yes. So, and how do we check that it will break copy? I mean, how could we check that it breaks copy and write? I mean, we should like monitor somehow this copy and write process itself.
So I'm kind of like, it's pretty, I don't know like how to answer you that question, but I guess it's pretty tricky like to figure out. I would maybe first, before starting this one, figure out how like compacting does work, because like copy and write, we use that in the forking. Like each memory page is like cloned into the process, but it's being copied on the first write to this page. So if you change any byte, it's gonna be copied into new replica. And now compacting, because it reorders blocks, so like it moves block from another page to another page, I would assume it kind of creates more of this copy on writes occurrences. I just don't know how to gather this metric. Maybe there's like some kernel metric on the process, like how much copy and write pages you have, and maybe compare that let's say from the outside, like you have the compacting, you know that compacting is working, so you have the compacting GC versus not compacting GC, and like you compare like how the memory pressure changes, how many unique memory pages is being allocated, or like actually you are looking about how many pages are being shared with the parent processes. Is it like how much this value difference between having compacting GC and not having compacting GC? So something around these lines. But now the question is like how you know that compacting GC is working on the Ruby 2.7? How you measure that? Is it like there is some metrics that you could use for that? Is it effective in our case? If not, like, so it's kind of like connected in like understanding how the GC parameters and compacting GC does work as well. Probably being good prerequisite for this topic.
Okay. I think to start today we'll take Puma single thread. Do you know how many threads do you run currently? Do you remember?
I think like you are talking about not single thread, because Puma always run in multiple threads.
Yeah, I mean.
You talk more about the single mode.
Yeah, single mode. Yeah.
So like the single process instead of multi-process. I think the number of the threads is not really that relevant. Like you still want to run as many threads as is possible, but because you don't have this copy on write thing and you don't have multi-processes, you only have a single processes, it should be like basically more memory efficient.
Yes, makes sense. Okay, I will try to investigate, and it will be possible. If it will be possible, I will also try to check the recent fork today.
What would be the second one that you would be looking at?
New fork of Puma, since it relies on the same, like.
I mean 5.0, right?
Yeah.
Cool.
It will be pretty like connect and easy to check together, and I hope it will be fast.
Nicola, how about you?
Just give me like maybe I can start with investigate the memory content, like see what is actually in the memory, dump a memory map, and like check what's in there. Maybe we can have a clear picture, and maybe it's a good way to start with all of this.
Cool. So I wanted to look at the use Spring for preloading. I'm just curious, like, is it hard? Is it doable? If it does work? It's not really like production ready, but I'm just curious, like, can it be made quite simple to work with the omnibus? So I guess we have topics, right?
Yeah.
Yes. Anything else we want to discuss before jumping in?
I think like right now, like, I'm not sure what else we may discuss. I think the more questions may pop up throughout the day or like tomorrow on the sync.
Do you want us to start like forking new issues? No. I mean, so until tomorrow, we need to fork like a couple of issues, right?
I think like it would be useful if you would like create the issue on the topic that you are working right now, and like as soon as you have like any details, investigation, interesting, like you just write a comment in this issue, like a log. So like,
Okay.
I mean, like so some people use like the notebook to note what they did and like what benefit they give them. So you may use like the, let's say, issue comments like in that form, like as a log of like what you were doing. But I mean, like Alexi, like it's my suggestion, but I'm not sure like if it works for everyone. So if you find like some other way, like to, let's say, to summarize that, maybe like pick whatever it's like easy, like, and like coherent, like with your usual workflow. So I'm kind of like thinking, like, I'm kind of looking for something that like each of us tomorrow could read, look at, and see like if it's actually something interesting for us to maybe to proceed, if you would like to proceed with something different, right? So I'm just curious about like having like the summary of like what you did, or like what everyone of us did, and like what benefit it did bring.
Okay. So Nicola, were you able to run this on Mac?
Yes.
Okay, good. Because I'm currently at this stage. Okay.
I had some troubles with localization, but I posted a comment in the thread with.
Yeah, I'll see.
It worked in the end.